Okay, problem number 1 says sketch the graph and label the vertex. So the first thing we're going to do is find the vertex, and we can see the vertex. You look for the 0, and then you look for this number. The vertex is at positive 3, comma, negative 5. So the easiest thing you can do is graph that vertex down there, and then since you know this is an x squared, you know this is going to have a 1, 3, 5 pattern. So remember that 1, 3, 5 pattern. And you're going to go up 1 and up 3 and 1, 2, 3, 4, 5, up 5. You've got the 1, 3, 5 pattern. That's the pattern that all parabolas make. Now, if you don't understand that, you can always make an XY table and just start plugging stuff in, okay? I think this way is a lot faster, so I would rather do the 1, 3, 5 pattern. Okay, find the vertex, do the 1, 3, 5, you've got the graph. Now, problem number 2 is now written in vertex form, meaning I can't see the vertex so easily, so this is where you have to use this formula. Negative b over 2a, comma, something. That's going to be the vertex. So look at your b number, it's 4. So negative 4 over 2 times your a number is 1. That's the number in the front. That's going to be negative 4 over 2, which is negative 2. Okay? So that tells me that my vertex is the point, negative 2, comma, something. Okay, that's my vertex. How I find that something is by plugging into the equation. So plug in the negative 2. Negative 2 squared plus 4 times negative 2 minus 1. Negative 2 squared is 4. 4 times negative 2 is minus 8, and minus 1, that's negative 4 minus 1, that's negative 5. So my vertex, negative 2, negative 5. Okay, now this positive 1 here means that I'm still going to have my 1, 3, 5 pattern. So I'm still going to go up 1, 1, 2, 3, 1, 2, 3, 4, 5. And draw your curve. That's about as easy as I can make that. Simplify square root of 32. You want to know your perfect squares, namely the ones that go into 32. The best way to do this is to break out your biggest perfect square. I like 16 because I know the square root of 16 is 4. That answer is 4 times the square root of 2. Now, sometimes someone will say, well, yeah, but what if I did this? Square root of 4 times square root of 8. You can do it that way because square root of 4 is 2. But the problem with square root of 8 is it can still be broken down more. 8 has a 4 inside of it. And so what you would have is 2 times square root of 2, which turns into the exact same thing as our answer. All right, so the best way to go is to find the biggest number like that 16. Square root of 16, square root of 2, that's 4 times square root of 2. Number 4 is pretty much the same idea, only with this negative, you know you're going to have an imaginary. All right, so it's going to be the same thing as like I times the square root of 200. And with that 200, just do the same thing that you did with the 32. Break something out of it, that's perfect. So on this one, I know 100 goes into 200. I can break that into square root of 100 times square root of 2. Square root of 100 is 10. So I'm going to have 10 times the I times square root of 2. Moving on. All right, this is just a matter of collecting like terms. You've got 1 plus negative 2 is negative 1. 8i plus 4i is plus 12i. That's it. This one is a distributive property problem. Number 6, you're going to distribute the negative 1, and you get negative 5 plus 8i. And then you're going to distribute the negative 3 and get minus 15i plus 24i squared. Two things now. Combine your like terms, that's going to make negative 7i there. But probably more importantly, I squared, you're supposed to remember that I squared is equal to negative 1. Okay, so 24 times negative 1 is negative 24. Now, if you put your like terms together, you've got negative 5 and negative 24. That makes negative 29 minus the 7i from before. Next, you've got an I on the bottom, and that's not reduced, so we're going to get rid of that I on the bottom in this way. We're going to multiply by a very special kind of 1. There's a lot of distributive property here. We're going to distribute on the top, and we get 3i plus 6i squared. Remember, I squared equals negative 1. On the bottom, we're going to have some distributive property as well. 1 plus 2i. And then distribute here and get minus 2i minus 4i squared. You should notice that these two things cancel out. That will always happen. But you've also got some I squareds. If I squared is negative 1, then you have 6 times negative 1, which is going to be negative 6. And you've got negative 4 times negative 1, which is going to be a positive 4. So clean this up. On the top, you have 3i minus 6. And on the bottom, you have 1 plus 4 is 5. As far as I'm concerned, that's the answer. But I know sometimes you'll have to split that up, and you'll say something like 3i over 5 minus 6 fifths. Either way, both of those are right. I to the 29th power. Okay, I to the 29th power, you have to remember a couple of special things. We know that I is the square root of negative 1. I squared, we know, is negative 1. So then it would follow that I cubed is I squared times I, which happens to be negative I. And I to the 4th, you can think of that as I squared times I squared. That's positive 1. It would help out a lot if you memorized those things. Okay? But I29, you want to split it up, basically. And there's a lot of different ways that you can do this. Okay? But what you want to do is look for multiples of 4. All right, so I want to split that 29 into multiples of 4 if I can. So I know 28 is a multiple of 4. I'm going to split I to the 29th into I to the 28th power times I to the 1st power. So what ends up happening is every power of 4, every multiple of 4 gets reduced down to 1. And so I to the 28th power is equal to 1. That means I have 1 times I to the 1st power, which is just I. And that's your answer. That's your simplified answer.